Good morning. Today let us continue the same unit 3. So in this session let us discuss about the uncertainty. So what do you mean by this uncertainty? It refers to situations where there is a lack of incomplete information or knowledge about a particular aspect leading to some ambiguity and unpredictability. That is what we call it as the uncertainty. And to overcome this uncertainty, generally we are going to use some techniques. Let us see this, in this session what are the techniques to work with this uncertainty. Till now we have learned knowledge representation using first order logic and propositional logic with certainty. That means we are sure about some predicates. That means with this knowledge representation we might write A conditional B, which means if A is true then B is true, but consider a situation where we are not sure about whether A is true or not, then we cannot express this statement. So such situation is called as uncertainty. So to represent uncertain knowledge where we are not sure about predicates, we need some uncertain reasoning or probabilistic reasoning. So one of the way to handle this uncertainty is the probabilistic reasoning. But before going to that, let us see what are the causes when we what are the reasons to there will be an uncertainty. So these are some of the leading causes of this uncertainty to occur in the real world. That is, information occurred from unreliable sources, experimental errors, equipment fault, temperature variance and the climate change. Then coming to the probabilistic reasoning, it is a way of knowledge representation where we apply the concept of probability to indicate the uncertainty in knowledge. Here in probabilistic reasoning we combine probability theory with logic to handle the uncertainty. And what is the need for this probabilistic reasoning in AI? When there are unpredictable outcomes, the one reason to need of probabilistic reason, when specifications or possibilities of predicates becomes too large to handle, and when an unknown error occurs during an experiment. These are some of the reasons we need the probabilistic reasoning in artificial intelligence. Okay. So in probabilistic reasoning, there are two ways to solve the problems with uncertain knowledge. In that, the one is the Bayes rule and second one is the Bayesian statistics. So in this session, I am going to cover about this Bayes rule. So before going to discuss about Bayes rule, we should have a minimum knowledge on probability. Already you are aware of this probability. So what is this probability? Probability can be defined as a chance that an uncertain event will occur. And we know that the value of probability always remains between 0 and 1, that represents some ideal uncertainties. Here where we call P of A is the probability of an event A, and when probability of A equal to 0 indicates that total uncertainty in an event A, whereas probability equal to 1 indicates that total certainty in an event A. So to find the probability of an uncertain event by using the formula, probability of occurrence equal to number of desired outcomes by total number of outcomes. Then these are some of the terminologies we are going to use for a particular probabilities. The first one is event. So each possible outcome of a particular variable is called an event, and the collection of all those possible events, generally we call it as a sample space. Then random variables are used to represent the events and objects in the real world. Prior probability is the probability of an event is probability computed before observing the new information. So before observing new information, what is the probability you are calculating? That we call it as a prior probability. And posterior probability is calculated after all evidence or information has taken into account, and it's a combination of prior probability and the new information. So conditional probability. So what is this conditional probability? Is a probability of occurring an event when another event has already occurred. So let's suppose we want to calculate the event A, okay, when event B has already occurred. So the probability of A under the conditions of B, how we are going to write is like this. So how we are going to read that? Probability of A given B. That means B has already occurred. Now we have to find out the probability of A. So is equal to probability of A and B divided by probability of B. So this particular representation is called as the conditional probability. So we know that this is the called as the joint probability of A and B, and this is called as the marginal probability of B. Okay. Then similarly, the probability of A is already given and we need to find the probability of B. Then we are going to write the same this formula in this way. Now here probability of B given A is equal to probability of A and B divided by probability of A. So, let us discuss one example which is related to this. In a class, there are 70% of the students who like English and 40% of the students who likes English and mathematics. Then what is the percent of students, those who like English also likes the mathematics? So, let us define first in terms of conditional probability the problem. Let the probability of English is equal to 70%. That is, the probability that a student likes English is 70%, and here also given 40% the probability that a student likes both English and mathematics. Then we want to find out the probability that a student likes mathematics given that they like English. That is given as probability of M given A. So, the formula we already known from the conditional probability. The probability of M given E equal to probability of E and M divided by probability of E. So, it is, we know that already 40% and divided by 70%, which is 57.14. So, that means 57% of the students who like English also likes the mathematics. In this way, with the help of conditional probability, we are going to get a certain knowledge of the particular problem. Now, next one more important one is Bayes theorem. So, one is Bayes theorem, one is Bayes in statistics. So, let us see this Bayes theorem. Bayes theorem is also known as Bayes rule or Bayes law or Bayes in reasoning, which determines the probability of an event with uncertain knowledge. So, in probability theory, this particular Bayes theorem relates the conditional probability and marginal probabilities of two random events. So, this Bayes theorem was named after the British mathematician called as Thomas Bayes. And the Bayes in inference is an application of this Bayes in theorem, which is the fundamental to this Bayes in statistics. So, it is a way to calculate the value of probability B given A with the knowledge of probability of A given B. So, let us see the product rule. So, the product rule in probability allows us to express the probability of intersection of two events in terms of conditional probabilities. So, here according to the product rule, when we take the probability that both A and B happen, which will be denoted as probability and A and B, we know that probability A and B is given as probability of A given B into probability of B. Similarly, okay, if we write here probability of B given A equal to probability of B given A into probability of A. That means the probability of A occurring given that B has already occurred. Here the probability of B occurring given that A has already occurred. So, these are the product rules. So, from this, as these both equations are same, okay, we are going to equate the two equations, okay. Then we are going to get, just assuming that dividing both sides by probability of B, then that particular equation can be written as probability of A given B equal to probability of B given A into probability of A divided by probability of B. So, this is the final formula, and this particular formula is called as the Bayes theorem. So, the resultant Bayes theorem is something like this. Okay. So, this is the Bayes theorem. So, where we call this one as posterior probability, this is the likelihood, and this is the prior probability, and this is the event. So, equivalently, the Bayes theorem can also be written as posterior equal to likelihood into prior divided by the evidence. So, let us discuss with one example how this particular Bayes theorem works. So, let us imagine a scenario like you are going for a test, okay, that whether you have a particular disease or not if the test comes back positive. So, this is a common use of Bayes theorem in real life, and it helps us to update the probability of a condition like having a disease based on new evidence like a test results. So, in this case, the hypothesis A is you have the disease, evidence B is the test result is positive. Okay, let us take this hypothesis and evidence from this particular problem statement. Now, posterior probability, the very first thing we need to find out is the posterior probability. Now, so this is what we have to find out. Posterior is what we have to find out, that the probability that you actually have the disease given that the test came back positive. That is what the posterior probability. Then likelihood, that is probability of B given A. Here this is the probability that test result would be positive if you really did have the disease. So, this is how reliable in correctly identifying people who have the disease. So, this is the likelihood. The next one is prior probability. This is the chance of having the disease before you even took the test. That is called as the prior probability. You haven't taken test, but you want to know the chance of having the disease. That is called as the prior probability. Then the next one is marginal probability, which is a probability of B. This is the overall chance that the test would come back positive regardless of whether you have the disease. Test is coming positive whether you have disease, regardless of whether you have the disease. So this combines, means this marginal probability combines the probabilities of true positives and false positives, where the test might show positive for people with and without the disease. Yes, sometimes even though we don't have disease, maybe the test result may come positive. In such cases, we are going to find out this marginal probability. So using Bayes theorem, we are going to calculate the probability that you have the disease given the positive test result by combining how likely it is that people with the disease get a positive result is likelihood, how common the disease is overall is the prior probability, and how often the test shows positive results in general, that is the marginal probability. So in this way, we are going to define the Bayes rule. Okay. So the next one is Bayes in belief network. Okay. So that is one more way to find out the handle the uncertainty. That this Bayes in belief network. I'll give the introduction. I'll stop the topic right now. Bayes network is a probabilistic graphic model which represents a set of variables and their conditions. So generally it is also called as a Bayes network or belief network, decision network or Bayesian model. And these are probabilistic. Why? Because they are going to build from a probability distribution and use probability theory for prediction and the anomaly detection. So it can be used for various tasks including like prediction, anomaly detection, diagnostics, time series prediction and decision making under uncertainty. So this is what just introduction to the uncertainty. And one of the method Bayes, we found some solutions, how when we have an uncertainty to find a solution for a particular problem, how Bayes theorem helps to overcome that uncertainty. And the next one is Bayes in belief network. So in the next session, I am going to explain what is this Bayes in belief network, or simply we call it as an BBN, with an example how we are going to handle the uncertainty in an artificial intelligence. Thank you.